on now, so I'll just get started. So my name's Eleanor Thompson. I am on the GSA Council, responsible for the automation workstream. I also work in the data integration space at a company called Fivetran, and I will be hosting today's session for you. So I'll just quickly take you through the running order and a bit about our fantastic speakers before kicking off. So first up, we have Manesh Tanna. Manesh is a solicitor, advocate and AI lead at the international law firm at Simmons & Simmons. Manesh is frequently invited to speak about AI legal issues, including recently by the United Nations, and he's going to be covering off an introduction to AI. Then we have Paul Morrison. So Paul is a principal in Hackett's business transformation team, where he leads Hackett's global smart automation practice. Paul is a visiting lecturer on technology at Imperial College London and will be covering getting value from AI. Then over to Daniel Gallagher. Daniel is a senior associate in the technology team at CMS. He regularly advises clients on the procurement and deployment of emerging technologies, and recently named Rising Star for FinTech by Legal 500, and will be covering contracting in AI. And finally, we have Imran Saeed and Mark O'Connor, both partners at DLA Piper. Imran has extensive experience of complex sourcing projects, and Mark is currently the chair of the Society for Computers and Law at DLA Piper's London client group, and together they'll be covering off governance, risk management trends, and move to regulation. Then we'll move into Q&A, and we'll finish promptly on time at 10:30. So Manesh, over to you.
Thank you, Eleanor, and good morning, good afternoon, everyone. I'm going to share my screen so you can see some slides that I'll speak to, and hopefully you can now all see those slides.
We can.
Great. So as Eleanor said, my name is Manesh Tanna. I'm a solicitor, advocate and AI lead at Simmons & Simmons, and I speak quite frequently on AI-related legal issues, and it's a pleasure to be invited by GSA to speak today at this session regarding AI. Now, I'm going to open the session by briefly introducing what AI actually is. It's becoming an increasingly talked about topic, particularly in current times where COVID is perhaps forcing businesses to digitalize and harness technology at a quicker rate. But I am finding that there is actually a misconception about what AI actually is. And in particular, in recent times, a confusion between AI and traditional automation, and a tendency to assume that just because there's an algorithm involved in a piece of technology, we're talking about AI, when that's not necessarily the case. A recent example is the A-level algorithm fiasco in the UK, and I've seen some commentary around that, criticizing AI. However, I think it's the case that actually that algorithm is very unlikely to have been based on artificial intelligence. And so I think it's important that we start off this session by discussing what AI actually is. Now, I'm going to do that by contrasting AI with traditional computer programming, which we've used for a number of years. Now, traditional computer programming involves giving a computer a set of rules to follow in order to arrive at a decision. And we've been entrusting computers to make decisions for decades now, principally because they can make those decisions quicker than humans. Now, the rules that the computer follows are often logic-based, following a if this, then that pattern to guide the computer to a decision. Take the simple example of resorting text in an Excel spreadsheet so that it's in alphabetical order. Now, the rules underlying that instruction might say something like, look at the first letter of the word, then put the A words before the B words after the A words, but before the C words, and so on. Now, importantly, those rules are set by humans. I've included on the slide a slightly more complicated example. Some of you probably receive alerts from your bank when a suspicious transaction is detected. Now, some of those systems are now based on AI. But 5 years ago, for example, it will have likely been a rule-based system like the one that I've put on the slide. Now, in this case, a computer will look at the amount of the transaction, and if it's over a certain amount, it will look at the transaction time, and following a set of rules made by the human, will decide whether or not there's been a fraudulent transaction. Now, the limitation of traditional computer programming is that in order to set those rules, humans need to understand the data. They need to understand what that data contains. For example, features of the data, in this case, the transaction time and the transaction amount. And they need to understand the data so that they can attribute a weight to those features. For example, a $10,000 threshold in this case. Now, self-evidently, if the humans don't know the data very well, then they're not in a position to set the rules for the computer with any accuracy. How do you know that $10,000 is an appropriate threshold in this case? How do you know that setting a period between 11 p.m. and 6 a.m. is the period during which transactions are more likely to be fraudulent? Without reviewing the data properly, the human can't accurately set the rules and can't create an accurate system. Now, the problem in today's world, of course, is that we have so much data. Now, we've all heard of this term big data, and I just want to conceptualize for a moment how much data we're talking about. The chart here shows how much data was created or used in every minute in 2019, and the figures are quite staggering. So just to give you a few examples, 390,000 applications were downloaded in every minute in 2019. 694,000 hours of Netflix were streamed in every minute in 2019, and there were 4.5 million Google searches. And I think the slightly scary thing about this is not just how much pre-existing data was transferred between sources or media, but how much additional data was being created as humans. All of those emails, text messages, and Twitter posts were all new data. Now, data is the fuel that drives AI. AI has actually been around since the 1950s, but it's more prominent today for two reasons, I would say. First, it's because we have so much of this data in digital form. And secondly, we have incredibly powerful computers which are able to process that data. Just to give you an example, Intel's latest processor can review over 8,000 images every second. Now, coming back to the example of the system I had on the previous slide about detecting fraudulent transactions, as I said, if you're designing the system as a conventional computer, you need to understand the data in order to set the rules. But with all of us making so many transactions in different places, in different media, at different times, it would just be impractical for humans to try and review and understand all that data and then set the rules for a computer program. It would end up, I guess, being a fairly inaccurate system. So the solution is artificial intelligence. And the essence of AI is that we no longer, as humans, set all the rules which the computer has to follow. Instead, we let a powerful computer processor review the data itself and, in effect, set its own rules. So how does that work? Well, on the slide is a typical machine learning system. Now, machine learning is the most common form of AI today. It sits alongside other types of AI, such as natural language processing and visual AI, such as facial recognition. Now, the essence of the system is that we feed all of this online digital data to the computer, give it some instructions as to how to review the data and the type of output we want, and we let the system go. To break that down a bit further, we start with an algorithm. An algorithm is just a set of instructions to the AI system about how to review the data. For example, we might ask the system to look at certain features, and we will say what output we want. For example, we will say we want a numerical score or a categorization system. Then we apply the algorithm to the data, and that becomes our AI model. Now, the model is just a piece of computerized code based on the algorithm and the data that the computer has learned. And that code essentially turns the input data into the output we want. But the model has to be refined and tested until it becomes accurate. And computer scientists spend a long time, often using training data, testing the system to make it more accurate. And one of the most time-consuming parts of the whole process is working with the training data, making sure that it's complete and accurate and that the computer can properly review it. An AI system is only really as good as the data on which it has been trained. When you hear in the news about AI systems going wrong, particularly in terms of discrimination issues, which is under increasing scrutiny recently, it's often an issue with the data on which the system has been trained. Now, the humans can either tweak the system themselves to make it more accurate basically asking the model to try different things with the data to see what output comes out. Or in more complicated systems, you can program the model to adjust itself based on the output it creates and based on human feedback. Now, we call it machine learning because the machine learns the data much better than a traditional computer does and much better than a human could do in the same time. The machine also learns from its own mistakes. It's programmed to become more accurate. And in some systems, it learns from human feedback about its decisions. And once the model is ready to be deployed, you can feed it live data and it can be used in the real world. Now, just because machines can learn, it doesn't mean that AI is in the realms of what you see in the Terminator or Matrix films, for example. That's still decades away, if not more. At the moment, we're in the territory of weak or narrow AI. That's AI that's capable of doing one task, but doing it very well. And the models that people are able to create are already impressively complex and sophisticated. You may have heard of concepts such as deep learning or neural networks, and a lot of the AI you see in the press is based on deep learning and neural networks. And on the slide is an example of actually what's a very simple neural network. It's a model designed to identify a picture of a turtle. And the way it works is that it'll look at each pixel in the image it's given and ask itself various questions. What color is this? What shape is it? And each of those decisions gives the model more information. And it goes through this layered process to arrive at hopefully the right answer. And as I said, the model will be programmed to learn from the data and make itself more accurate. So at each decision, the layers and the decision making can be updated to become more accurate. And the humans overseeing the system can also tweak the model depending on the output they see. But here is where it gets tricky. These models get so complicated that often the humans lose sight of what's going on inside the model. So the humans are tweaking the system, but they don't really know what they're changing. They can just see that the output changes when they do something. And this is a relatively basic system designed to identify an image of a turtle. Imagine how complicated the models are which move driverless cars. And in these circumstances, we say that the model is operating in a black box. It's difficult to explain how the model has reached a decision. In other words, why, given certain inputs, the AI model has reached the output it has reached. And it's also difficult to predict how the AI model is going to behave in the future with a different set of inputs. And this is why AI is, on the one hand, so powerful and really has endless capabilities. Humans no longer need to worry about reviewing the data and setting the rules for the computer to follow. That's an automated system. Instead, we let a very powerful processor review the data and create its own rules to identify the correct output. That's artificial intelligence. On the other hand, it's also why there are so many concerns about AI. One way of thinking about it is that rather than being automated, it's technology which acts autonomously. And that's why there's so much focus on ethical and responsible AI and increasing noise about regulation for AI, which is something we'll hear more about later on in the session. Now, I'm going to stop there. I'm happy to answer any questions later on or after the session, but I'm going to hand over now to Paul, who'll be discussing more about the capabilities and value of AI.
Minesh, thanks very much. That's great. An amazing amount you've covered in just 10 minutes. So kudos there. Thanks very much, and thanks to the GSA for inviting me today. Yeah, I'm going to cover getting value from AI and give 10 minutes of pointers on that subject. Before I do, just really quickly, I lead the digital enablement team at the Hackett Group. For those of you who don't know us, we're 1,200 consultants focused on helping clients to get the best possible performance from GBS and back office through benchmarking and consultancy. And yeah, I lead within that team focused on helping clients to get the value, the maximum value they can from emerging digital technologies such as RPA, analytics, and AI. So with that, in terms of getting value from AI in 10 minutes, I'm really going to give 6 core messages really for putting AI in context so you can approach it and tackle it as a buyer or a user. And the key messages are these. Firstly, that AI is a complicated family of technologies, as Minesh was pointing us to there. Secondly, it's almost always applied in the context of other digital technologies that need to be understood. Thirdly, AI is consumed in different ways. It's not simply made or bought. There is quite a complicated make or buy decision around that. Fourthly, AI only really creates value where it's properly integrated into the work of an organization and really clearly understood how that happens. Fifthly, it's important to see AI as an investment and think through the implications of that. And then finally, in terms of sourcing and outsourcing, your service providers can help, but you need to retain control. So I'll just take us through those in slightly more detail. And first up, meet the family, and Minesh absolutely spot on there, talking about machine learning as the sort of primary or most often talked about mode of AI at the moment, but not the only one. And I think the key point I want to make here is not that this is the right way of decomposing that really complicated concept of AI, but that it is not a single lump. When we talk about AI, there are different types of technology and technique, primarily around computer science, that are being used. Almost all of them are to do with imitating complex thought processes, particularly to do with judgment, learning, pattern recognition. But behind the simplifications, there's a very wide range of techniques under the bonnet. And that means when you're trying to get value from AI, you need to recognize that and not treat it as one thing. In that sense, it's very different to earlier waves of digital change, such as RPA, which were fundamentally the same and of one type. Secondly, AI in the mix. Absolutely, again, Minesh was right to say that there's a lot of confusion about the blurring edges of AI and the fact that it's not automation. Absolutely right. It's also key to recognize that when you get to deploy, let's say, an AI automation around fraud analytics in insurance, you almost always will want to do that with a wrapper of automation around that, for example, or an analytics element connected to that. And it's very rarely the case that AI stands alone. So back to the question about getting value from AI, you cannot, it's very rare to be able to achieve value, get value in a vacuum. You need to think about how you're going to deploy it, how you're going to automate it, because in particular, AI can be powerful because it can be scaled. And therefore, you need to really think about how your AI projects are connected to the wider digital initiatives that you have. And again, there's difficulty, and we don't have time to go through a lot of detail on this, but the point is these three A's, as we call them, are different. They come from different directions. Automation is to do with process and continuous improvement and the 50 years of IT that we focused on. Analytics is to do with data and statistics and reporting and the practices and disciplines around that. And AI is fundamentally driven off computer science and techniques around that. These are different origins, but they come together in companies today most powerfully where they overlap and reinforce. And that's a really key thing to understand and why it can be so complicated. Thirdly, make or buy. And I think it's really important to recognize that if you are a head of finance, head of HR, head of procurement, whatever, and you are looking to benefit and to move forward with AI, there are different ways that you can do that. Over the past 10 years, as a lot of progress has been made in the space, a lot of it has been bespoke. So large organizations, the largest organizations doing R&D, developing a lot of the infrastructure and techniques, think of Google and Amazon, and putting together and creating AI capabilities that are powerful, well-beating, but starting really from the ground up. And it's still possible to do that, either from first principles, but more commonly using some of the open source components that are available now. Secondly, it's also possible to get AI off the shelf. So there's a very wide, massively wide range of applications that are out there that enable you to configure and design your AI, where a lot of the mechanics, the maths, the computer science is pre-configured with pre-configured models that enable you to really accelerate the process. The downsides of this is that you're not creating something new. It may be less potentially attuned to your needs, but the reality is, for example, if I'm using AI to capture invoices and to understand different structures, the real range complexity of invoices, if I use an AI-powered tool that has been pre-configured around that problem, that will solve most of my issues. And therefore, a lot of the focus, a lot of the routes to getting AI is through this second approach. And then thirdly, AI, frankly, is everywhere. So if I'm a user of SAP or Concur, to the T&E module within SAP or Salesforce or any number of other applications, these services, software as a service, will be and have built-in AI functionality into these softwares and these services, and therefore you can buy the impact of AI where it's really thoroughly baked into a product and almost imperceptible at the start, and therefore it's stepping back, thinking about how do you get value. The economics of each of these different routes is very different, and a key thing to bear in mind. Point 4, perhaps the most difficult angle, I think, for getting value from AI is to recognize that AI is it's a new way of doing work. It's a new way of approaching a part of the process or value chain that we have as a company. That may be in the way you sell, in the way that you do finance, the way that you manage and train your employees, but it's a new way of doing work. And the key question is precisely what work is the AI to do? What angle of a process can be augmented or improved using AI? And being very precise around this is, I'd say, the most difficult challenge, finding that opportunity, finding where that value can be created. And here's a simple example from the procurement process, source to settle. And if you look at the value chain, in blue, there are areas we've highlighted here where we've seen AI deployed. If you look at the evaluate and negotiate section at the top, we saw Deutsche Telekom using AI-powered chatbots to do pre-negotiation with low-value item suppliers and achieve a 7% saving in the pricing that was being offered. So it's a simple example there. In the supplier payment space, Wipro and a retail client used AI and predictive analytics to reduce false, unnecessary or fraudulent payments by 2%. So small percentage on a very big number. The key point here is you really need to spend a lot of time understanding where in the process AI is going to have an impact, because it's simply not the case that it can work everywhere. Point 5, thinking about the return on investment. If you think about every digital project you have and every AI project you have, some of them will be highly successful. They will pay back quickly and they will generate high cumulative benefits. Some will break even with a lower benefit, and there are some that fail. And if you look at AI and the success rates so far, around about a third of AI projects to date don't really succeed. They're in that failure zone, and only 5 to 10% really excel, really achieve high return. And this is in part because it's still relatively early days in this space, and it's also down to the complexity. And it's important to think through on the previous comment, the precise opportunity you're targeting, and also to think through in very clear terms the value that can be created when you are applying AI. And what we found at Hackett using our DIVA database around digital value is that there's a very clear correlation or segmentation of what organizations are achieving with AI and other digital initiatives. And it's really, we see a set of what we call stars, really high performing AI and digital investments where they are focused on influencing outcomes within the business. So back to the Wipro retail example, where they're looking to change the amount of money that's paid by the business. They're looking to reduce fraud, where Deutsche Telekom is looking to reduce procurement costs. Where AI can be connected to a business outcome or business decision, you can have a really big impact. Where you're focusing on efficiency, you can have significant impact, but many organizations have frankly applied efficiencies over many decades, and the opportunities there are less dramatic in many ways. And there's a third category where the complexity of an AI project and the return for that is actually relatively slow, and payback may only occur over a number of years. So I have to move on, but I think having this mindset of thinking about the value, the cost, the payback is a really important discipline, and it's a discipline that we see with the strongest performers in this space. A few other really quick considerations around ROI is going to vary massively depending on where in the process and how you're buying AI. Secondly, as Manesh says, the data wrangling integration element and training element is really significant, and that's often the biggest part of the outlay, and that needs to be focused on. Thirdly, there are ongoing costs to that data management, training, maintenance that are somewhat different to other technology investments and perhaps higher than organisations realise at the outset. Point 4 on outcomes I've touched on. And then finally, getting AI to work like other digital investments requires putting in place a series of capabilities, and I'll touch on that in more detail in a second. And then finally, my final point around sourcing success. Can you use an outsourcer or a service provider to help you on this journey? And I would say absolutely, in the same way as with earlier waves of service work and outsourcing and transactional work, there are clear benefits and clear trade-offs in working with a service partner. When you work alone, you retain control, the simplicity, but you lose that ability to tap into expertise, perhaps lower cost models, and other IP and assets that an experienced service provider or specialist may have. And therefore, it is absolutely a valid route to think through how your service provider can help you on the journey. If you think about back to our sort of end-to-end processes where AI opportunities are scattered and you're a user of outsourcing, then there will be those strong high potential opportunities scattered across the outsource scope, but also retained. And therefore, if you're going to work with a third party on AI problems, you'll need to understand how that plays across both sides of the fence, retained and outsourced. But the key point is, in working with a service provider or a third party, whether they're providing experts, whether they're providing tools or technology, regardless of that, you need to retain control of this in exactly the same way as outsourcing or transactional activities. And what we see in digital and AI is to make it work, you need a sequence of capabilities that get you from an idea about how AI can create value to real value generation and being realized year after year. There needs to be a sequence of a clear strategy, this clear data infrastructure, a COE or a home for the talent and ideas around AI that you generate, really clear opportunity identification, and then you need people to configure, train, deploy, run what you're deploying, and that sequence needs to be in place. And you may get your outsourcer to help you with one or more of these steps, but the big picture and the strategy you need to retain control of. With that, I think I've used up my airtime and oxygen, and I will hand over to Daniel.
Thanks very much, Paul. There we are. Okay, someone's leaving. So my name is Daniel Gallagher, and I'm a senior associate in the technology team in CMS in London. I hope you can see my slides.
We can.
So you can, good, great. So I'm going to talk about contracting for AI, and I found the two sessions that we've had so far have been very interesting, and actually a really nice segue into what I'm going to talk about for the next 10 minutes. So in the 10 minutes or so that I have with you, I'm going to illustrate why I think we need to approach contracting for AI in a different way that we approach contracting for more traditional technology, highlight some areas of contracts that will be familiar to you when you're contracting for technology, but which we may need to approach differently when we're contracting for AI. And then lastly, to provide you a few tips that I have that I hope will help when you come to thinking about procuring and contracting for an AI system. So thankfully, Manesh has given us a nice introduction and an overview of an AI system, and he picked out in a diagram, a nice diagram about the different elements of an AI system. And I think it's quite important to have those in mind when you are approaching your contract for AI. And just to run through those very quickly, you've got the tool itself, you've got the training data and the training instructions, which, as we've heard already, important part of the whole procurement process is thinking about what you're doing with the training data. You've got the production data, which is the data that gets run through the system once you've trained the tool and put it into live production. You've then got what I've called AI developments, which is how the tool may develop over time once you've started using it and running the production data through it. And then you've got the output, which is what comes out of your tool at the end once you've run the production data through. And just to put that in a couple of very quick examples so you can see how those elements feature in a system. You've got here, this is a AI being used to help with the underwriting of health insurance. So you've got the tool here, which you'll train with some data and some training instructions. Once you put it into production, you'll have data coming in from maybe an individual giving some data about their health, might get supplemented with some other production data that is held in a data store. The underwriting algorithm and the AI analytics run the production data and then push out an output, which might be offering someone insurance with a risk calculation and then a premium that goes with it. One other quick example, machine perception and predictive maintenance. So again, you've got your tool here that you've trained with some data and instructions. Your production data, in this case, you'll have sensors that are in a wind turbine, for example, that measure vibrations, send the data into a data store. You might supplement that with some data that you've got in other systems. So that's your production data, goes through the predictive maintenance analytics, which then pushes out some alerts if certain thresholds are met, and an analyst will look at those and then decide whether or not to deploy an engineer to go and look at the asset and maybe do some work on it. So that's a quick overview of how those elements might work in a system. And as I say, it's important to have all of that in mind when you're approaching your contract for AI. So I want to look at it in the context of a key contract area, which is use rights and ownership, to illustrate how, when you contract for AI, you may need to approach things that are typical parts of contracts we might need to approach in a slightly different way in the context of contracting for AI. So the rights in the actual AI tool itself most likely are going to be owned by the supplier and then licensed down to the customer. And that's probably the most straightforward of those AI elements to think of when you're thinking about use and ownership. When you think about training and the training data, you'll need to deal in the contract with which party is going to be responsible for doing the training, for training the tool, who's going to procure the training data and who will be responsible for preparing that data to use in the training process, who will then be responsible for training the tool, so giving it the instructions, and then also, who will actually model and tune the algorithm and prepare it for live use. If you're going to be the party that will be responsible for providing the training data, then you'll need to think about what third-party rights or contractual limitations there are on the use of that data that maybe need to factor into the contract. And it's likely that if the customer is bringing some data that they have, it could contain confidential or commercially sensitive information. And in your contract, you'll need to think about how you deal with that in terms of undertakings and obligations around use of that data when the supplier uses it in the context of running the system. And there may also be some other legal restrictions on the use of the data. So, for example, if the training data has personal information in it, you'll need to think about how you're going to comply with data protection laws. So there are those things that you'll need to deal with in the contract. When it comes to the production data, if it's an on-premise solution, so run entirely in your environment, it's likely that it's only going to be running data from your environment. It may not, but it's likely that it will. If it's cloud-based, it's probably going to run your data plus data from other customers of the supplier. So if you're using a cloud AI system, it's likely that the supplier is going to want to have some use rights in your production data in order that they can improve the AI tool and then evolve it. So if you're the customer in that situation, you need to think about whether or not you will allow that. is there commercially sensitive information in there that you want to put some restrictions on use, and maybe you want to pass on an obligation for the supplier to do some data cleansing so that they can take out any particularly sensitive information before they can use the production data. When it comes to the AI developments, you'll need to think about who's going to own those and then who's going to have rights to use them. So if the solution is a dedicated solution, so it's deployed on the customer's servers and trained only with their data, that may be a situation where if you're the customer or you're acting for a customer, you can push for ownership rights in those developments. If it's a cloud-based solution, it's a bit more complex. It's most likely that the supplier is going to want to own the developments in the AI tool, and if you're the customer and you won't own the developments, then you'll need to think about a license back and making sure that you have the most up-to-date version of the tool always, and you'll need to deal with what those developments mean in terms of pricing and whether those are included within the price you're paying or are going to be things that you'll have to pay extra for. And then finally, you've got the outputs, and again, you'll need to think about who owns these and who has the rights to use them. It's probably most likely that the customer will end up owning the outputs, and the supplier will want some ability to use them again to evolve and develop the tool. And you'll need to think about, if you're the customer, you'll need to think about whether you need to put any restrictions on use in the data or do anything with the output data before the supplier gets to use it. So hopefully that and thinking about those things I've mentioned there. So hopefully that illustrates an area of a contract where you may need to approach it thinking about each of those 6 elements of the AI system when you're thinking about how to deal with ownership and use rights. And there are other key areas of difference in technology contracts that you'll need to think about when you're contracting for AI. Don't have time to run through all of them today, but I just wanted to flag what I think those are. So you've got use and ownership, which we've taken a look at. Non-infringement of intellectual property, there'll be typically reps and warranties and indemnities around that in a technology agreement that maybe need to adjusted to cater for the different roles of the parties in maybe providing the training or which party is doing the bringing the data. You might need to deal with that differently. Performance warranties around performance of the tool in accordance with specifications or documentation where you've got a tool that is evolving, those performance warranties may need to be adjusted. And then compliance with laws and governance is a really important area of the contract. And we've already touched on the fact that, you know, an AI tool can make decisions that have legal consequences for people and therefore may lead to things that are actionable in law. So an important part of your contract is dealing with how you mitigate some of those risks. Now, some of that will be done outside of the contract, but your contract will need to think about data management, thinking about modeling and monitoring the tool. So looking out for where it might be behaving in ways that you don't want it to, or where the model has drifted. Thinking about transparency and explainability, that will be an important part, that you've got the ability to try and understand how the tool is working. Audit and record keeping are linked to that and very important. And then thinking about organizational governance, so maybe having ethical policies and committees that oversee the use of the AI. So finally, my tips for successfully contracting for AI. First of all, due diligence and selection, and I think Paul has touched on that already, really important stage of the contracting process. So thinking about whether, for example, you take a tool that works on premise or will be cloud-based, that will have a big impact on how you approach the contract and the outcomes of those areas that I've highlighted. Transparency and explainability, you'll need to decide what level of transparency and explainability you need from the tool. If you're a regulated customer, you may need a higher level of explainability, and you'll need to think about whether the tool can give you that level of explainability and whether the supplier can help you at all, or how you'll mitigate it where there isn't that level of explainability. And Manesh has already touched on how that can get very complicated where you have these neural network capabilities and a black box tool. So thinking about that from the outset is really important. Otherwise, you could end up with a very difficult negotiation. Then looking at your standard technology contracts and being aware of the key areas of difference, which I've touched on. And then finally, what I've called some guiding questions, which hopefully when you think about each of those AI elements and working through those in the context of your contract, you can ask yourself these questions, and that hopefully will help you with the outcome. So thinking about who will provide that AI element, thinking about which parties are going to have the use of the element, and then finally thinking about how the element will be used. And hopefully by working through those, you'll be able to arrive at the outcomes that you need when you're negotiating your contract. So I'm going to pass over now to Imran and Mark, who are going to talk about governance and risk management trends and regulation.
Great stuff. Thanks, Daniel. Hope you can hear me. This is Mark speaking, and Imran's going to flash up our slides in a second to accompany our next few moments. That's a great segue, Daniel, to what we want to talk about. And we want to add the last perspective, really, for this morning's session. Imran and I are part of our wider AI team at DLA Piper, working on the global evolving AI regulation and guidance. And that's what we want to talk to you about today. So I'm going to tee that up by looking at the emerging regulatory environment across the world. Imran's then going to delve deeper into the findings from our work and specifically how you make AI policy real. And that's to answer the question, what law applies? What law applies to this contract, to this technology, and how do we make sure that it's going to work going forward? How do I deploy that complex technology as part of an outsource or some sort of digital transformation project in a way that's going to work legally for the, say, 5-year term of the agreement? So as we know, as the slide says, AI represents great opportunities, and that's been discussed already by colleagues on this call. And COVID's really shone a light on that, hasn't it? It's shone a light on the deployment of technology. There's been a scramble to work from home, an uptick in skills and awareness. We were talking to the CEO of Snapchat the other day, who reckons that technology adoption deployment has leapt forward by something between 4 and 6 years. That's fantastic. But at the same time, we have seen something of a tech lash, helped by the failed COVID world-beating track and trace app, of course, and the off-call algorithm. Whether or not they were AI issues, they have dented the trust in technology. And trust is a key concept here that we've been looking at. There was a survey this week published by the EU Observer, which said that only 20% of those surveyed trusted the current rules around AI, which is pretty low. At the same time, we've got the ICO coming out with pronouncements such that boards are responsible for signing off new technology approaches. That means people on boards, not necessarily technology savvy, are having to understand bias, discrimination, having to understand the pros and cons of deploying different types of tech. So we need some sort of risk-based assessment, some sort of ethical oversight framework that can cater for new tech and new regulation. Imran, if you don't mind clicking onto the next slide. As I think colleagues have said and said well this morning, any successful AI strategy is going to need to be sustainable and future-proofed. The points on the slide, in a sense, echo what's been said before. Reputational risk is clearly an issue, keeping you off the front pages unless getting on the front pages is part of your strategy, of course. But anticipating future regulation, that's the key. You can spend a lot of time right now creating something that then gets thwarted if the rules move to the right or to the left. So earlier this year, just before lockdown, in fact, we held an event along with the IEEE, and we had speakers from the European Commission who were waving their white paper and the draft regulations for AI, along with the Council of Europe. And we were lucky enough to have Tim Clement-Jones, who you probably know was the chair of the House of Lords Select Committee. Now, that brought together, even just that small collection, brought together different perspectives on regulation. The Council of Europe, as many will know, is a human rights based organization. The IEEE have their much lauded 4 pillars for AI. The Commission, its white paper, of course, looking at risk-based regulation, looking at different sectors, those it would designate as high or low risk, to have a different sort of regulatory environment. Pretty confusing. And as the conversation went on, it increasingly became clear that these were just 4 perspectives, and there are so many others around the world. They overlap. One here will have 6 pillars, someone else will have 4 principles, someone else will have 10 guidelines, and so on. So how, if you're an organization trying to develop and deploy new tech, how do you future-proof yourself? So Imran, if you don't mind going on to the next slide, that is the point that we thought there's something that needs to be done here. You've got to crunch into the regulations to seek to distill the key principles and come out the other end with a blueprint, essentially, for how to deploy tech. So we've looked at all those on the slide, plus others, the Singapore model on AI governance framework, the CDEI AI barometer, Ada Lovelace and Turing, and of course G20, OECD. So we've gone through those to try and distill the common themes. And on the next slide are those common themes in high-level terms. In doing so, we've developed a tool, a maturity assessment, that allows organizations to think about the use case deployment of their new technology, but it's set against the outcome of all this crunching of data from around the world, so that what comes out is either a thumbs up maturity assessment that your deployment is being done in the right way, or a list of things you need to think about. I don't need to read the slide, and Imran's going to unpack this for us in a minute, but accountability is a key one there. The public sector guidance on AI, for example, is that accountability is an end-to-end governing principle, and you start to think about what that means. That's a big issue. Fairness is another one, which is easy to say, but whose decision is it as to what is or isn't fair? And accuracy, of course, goes to trust again. But in all cases, it's underpinned by good corporate governance on two axes, top to bottom, end to end, board level down to the daily execution, and from start to end of each deployment. If that is done right, and the governance is in place and is evident to customers, suppliers, supply chain, consumers, and so forth, that then results in trust. That's the magic sauce here that everyone needs to think about to raise that disappointing 20% assessment. Okay, so that's the backdrop of sort of very quickly global regulation and the issue, the question: how do you cater for different regulations evolving in different places? Having done that crunching, what does that mean in practice? I'll hand over to Imran to unpack that for us.
Thanks, Mark. So as Mark says, I'm going to take a look through some of those themes now and draw out some examples of what that might mean in practice for an organisation, because obviously we're not going to have time in the session today to go through all of it. But as Mark said, what's very clear from the array of guidance is that the starting point for managing your risk in the AI space is governance. It's to ensure that your organisation has a framework in place that builds compliance and ethical thinking into every level of the organisation, and that it operates on a multidisciplinary basis. And this is the bedrock, this is the foundation that needs to be established to create the lens and the tools that you'll need as an organisation to look through any of the issues that I'm about to come on to. So there's no one size fits all to these issues, and most of the guidance recommends a risk-based approach. So taking this risk-based approach, there's some lessons that we've drawn out that point to a good level of organisational maturity around AI. Note we say maturity rather than risk, because organisational maturity allows you to make those risk-based decisions in an informed manner. So it starts at the beginning with the use case, with a stress test of why you intend to use a particular technology. And of course, just because you can doesn't mean that you should. And so a key step of any AI or other complex technology use case assessment is to think about the impact it's going to have on people, whether that's consumers, employees, or any other class of impacted individual. More mature organisations will build ethics policies and put higher risk activities through ethics committees, again comprised of a multidisciplinary group and aligned to the broader CSR principles of your organisation. And as one of the speakers mentioned earlier today, if you're regulated, the regulators themselves might have their own view of what promotes trust in your sector and what use cases are therefore appropriate. For example, we can expect the financial services sector to show enormous sensitivity over pricing solutions and how increasingly personalised pricing might have the effect of excluding certain consumers from the market. So then you come on to think about how you design, develop, and build your solution. Unsurprisingly, training data is a key common theme in the guidance, particularly around building an ecosystem of trust, an ecosystem of excellence. In particular, the EC white paper on AI has proposed a requirement to maintain records of the selection process and the characteristics of training and testing data, to maintain records of the methodologies used to program and train your solution, all with a view to having a depth of understanding about how your solution will function and an ability to the greatest extent possible to trace back and verify your decisions, both as an organization, but also with a north eye to external scrutiny, to the kind of scrutiny that the market might want to impose or that regulators might. We also think about ethics by design, leaning heavily on data protection principles. Ethical principles and controls should form a core pillar of the design and development process. So organizations need to determine what bias risks or discrimination risks might exist, document those, and document and implement mitigating steps to address those risks from the outset. And that starts at the design phase to make sure that there's a strong foundation to build the solution in the first place. And finally, testing is also going to be critical. Parallel running of traditional decision-making with AI-driven decision-making is likely to form a cornerstone of good AI risk mitigation for higher-risk solutions in the future. So turning then to transparency, which is again a topic that has arisen over the course of this morning. So the European Commission view is that lack of trust is a key factor holding back the broader uptake of AI. And so clearly this means different things at different levels. And we've drawn out kind of three core areas here. First, user transparency. Organizations need to be clear, not just about the fact that they are using AI, but also what the purpose of an AI tool is, what its capabilities are, and potentially what its limitations and even the risks of the systems to the end users might be. Second, the systems themselves need to be robust and accurate, or at least have a predictable level of accuracy, perhaps around KPIs. Outcomes should be reproducible, and to the greatest extent possible, errors should be capable of being understood and fixed. And this also means security. Like with any technology or data product, there needs to be resilience against attacks and the potential for manipulation of data or manipulation of the algorithms themselves that might act to the detriment of people and end users. And then finally, this all needs to be wrapped in accountability. Going back to the governance structures we talked about before, human oversight will remain the standard for managing AI risk at all stages. It's not just about accuracy, but it's also about recourse and establishing procedures for rectifying issues based on clear record keeping. So just to wrap up, as we're running out of time, looking at these common themes, it's very, very clear how they permeate every stage of the AI lifecycle, from the use case assessment to the design and the development of a solution, to the contracting, which was talked about earlier today, and the vendor due diligence, and then all the way in to the ongoing operational monitoring and governance controls around your AI solutions and your overall AI risk strategy. And there's no one size fits all. As we said, the guidance mostly recommends a risk-based approach. And of course, to take a risk-based approach, you need to be mature enough as an organization to fully assess those risks and choose which ones you want to take. So that's all from Mark and I, unless there's any questions in the final part of the session. So Eleanor, shall I hand back to you?
Yes, thank you very much. Thank you everyone so much for speaking. We have one question in the chat, and then I'll move to see if anyone wants to say their question out loud. So the question in the chat, I think, is probably for Daniel. But to what extent are you seeing granular service levels and performance obligations, and also wider contract obligations around transparency and explainability, accountability, including liability? All aspects addressed in many guidance documents out there. These terms don't tend to match up with the guidance and are just a very high level with no acceptance of risk by suppliers.
Okay, so my thoughts on that. So I think in terms of the level of obligations you might see in the contract, or the way that the contract deals with issues of, for example, transparency and explainability and accountability, will depend on what the AI is used for, and how, I suppose, picking up some of the comments that Imran was making, and Mark at the end there, about the effects of the AI on individuals and consumers, and if you're using a tool that is going to be making decisions that will have impacts on them, and if you're operating it as well in a regulated environment, so you may have some regulatory obligations in terms of explainability, treating people fairly, as well, you are likely going to seek some contractual obligations, and you might see some parts of the contract dealing with the ability of the customer to get the supplier to help them to understand how the decisions have been made. It will be maybe less of a concern to you if you're deploying, for example, AI for predictive maintenance. If you think about that example, where you may be comfortable holding the supplier accountable through the service levels, rather than having a need to understand absolutely how the decisions have been made, if all you're interested in is the end result, which is whether or not I should go or when I should go and do some maintenance on an asset. In terms of just touching on performance obligations, I mentioned about how warranties might need to be treated differently. I think what you might see, and what I've seen done in contracts for AI solutions, is when you get to the warranties, thinking more about outcome-based warranties, so thinking about what the end result of the AI tool is meant to be, what it is you want as the output, and you have to think carefully about how you do that, but you focus on that, and the tool can evolve along the way, but still meet the performance warranties. So those are my thoughts. I don't know if anyone else on the panel has some other views that they can share.
Yeah, I'll just pitch in briefly, Dan. That's really helpful. So it's Minesh here from Simmons. Sarah, you're absolutely right that we're not seeing an acceptance of risk by suppliers. And I think the key reason is, and as we're seeing at Simmons, is that purchasers will put in very broad and high level proposals for protection. So, for example, they'll propose that the supplier should give a broad warranty about the transparency or accuracy of the AI system. And of course, the supplier is not going to accept that because it's just too broad. And so what we're trying to encourage purchasers to do is be more granular in the protection that they're seeking from suppliers. Insist on compliance with particular GDPR articles like 13 and 14, which require meaningful logic to be explained about the system. So the more granular you can be, the more likely suppliers are to accept some sort of risk. But I think you're right that the trend at the moment is very general protection is not going to be accepted by suppliers.
Brilliant. Thank you so much. Sarah, I hope that answers your question. If not, then drop us an email and we'll provide some more information for you. I think that's all we've got time for. But if anyone does have any other questions that they want us to cover off, please email them over to us or drop any of us a message directly and we'll get those answered for you. But thank you all so much for your time.
Thank you.
Thank you. Bye.
Thank you.
Thanks, Eleanor. Bye.
Thanks.
Bye-bye.
Bye.
Thanks, Phil.